weird spaces. That's nice. How many people were at my talk this morning? Just so I know. Okay, so quite a few of you. For those of you that weren't, I will do part of what I did this morning. For those of you that were, some of it will be a little repetitive. I just want to make sure that everybody knows what Dapper is, because it sort of sets the context for this talk. And especially because this is a small room, absolutely feel free to ask questions throughout. This is for you guys, like the content, I have a bunch of stuff prepared, but I'm really happy to talk about anything that you guys want. So. Okay. First of all, a little bit about myself. My name is Jon Aizen. I live in San Francisco. I'm the CTO and founder of a company called Dapper. Most of our people currently are in Tel Aviv. Some of us are in San Francisco. We're about 2 years old. We're funded by Excel Partners, the same investors who funded Facebook and Macromedia, Real Player, amongst many other very compelling companies. We're about 18 people today, again, with most of them working in Tel Aviv, Israel. My background, as you may have read, I've basically been working with the web since like 1994 when I started building web apps. There weren't really so much web apps as websites at the time, and there wasn't so much web engineering as web design at the time. And so I've been fortunate enough to sort of be a participant in its evolution over time. So again, if you guys have any questions along the way about anything I'm talking about or myself, just feel free to ask. I'm going to talk to you guys today about patterns for building mashups and something that Dapper's released called the Mashup Data Server. I also refer to it as the Dapper Feed Services. I'm sorry for the inconsistency in the naming. It's just something we call it one thing and the presentation calls it another, and so I get a little mixed up. But it's all the same stuff. But before we dive into all that, it would help to sort of have a background with Dapper. I'm going to do a demo here, provided my internet works. Basically, it is a platform for creating XML feeds from websites that are in HTML. Okay, so for those of you who are, by the way, just so I know, how many people here are like technical? How many people here know what HTML is? Okay, great, good. And so I take it you guys also know what feeds are then, yeah? Okay, cool. So if you guys look at an HTML website, or if you've ever tried to parse content out of an HTML website, you know that it can be very difficult, because HTML is geared towards rendering and layout, formatting, not towards anything that a human really understands when he's writing a computer program. So you might see bold, and you might see divider, you might see paragraph, but you never see something like movie title or description, right? So Dapper really tries to make this mapping between what a user sees, which is sort of semantic understanding of a website, and what a computer sees, which is HTML. And HTML, like I said, is a big mess, and so making this mapping is non-trivial. And I'll be happy to talk about the algorithms that we use and the practices that we use in order to make this possible. A couple other things to note. It's entirely web-based. This has been our approach all along because it makes it a lot easier to sort of get up and get started. We're trying to reduce the barrier as much as possible. So both the creation portion, when you go and you create a feed for a website, is done in a web-based environment. And then when you use it inside your application, it's also done over the web. You just make a call to URL, you change some of the parameters in the URL, and you get back the content that you need. It's intended to be robust, reliable, and pervasive. So what does that mean? Robust in the sense that as a website changes, the feed should continue to work, should continue to adapt to the way the website changes. And we can talk about how that's done. It's interesting. Reliable in the sense that we strive to provide a service that you can rely on in your software. You don't have to worry about our servers going offline or us disappearing tomorrow and so on. And there's a number of ways we ensure that. And to be pervasive effectively means that we want Dapper to work on the entire web. Now, every website, I can tell you from my own experience, is built differently. Most of them are built poorly. And being able to support something that works generically and lets you extract content generically from a website is very difficult. So probably today we have something like 75% coverage. It's actually something that's very hard to measure automatically. But based upon user feedback, there's a good portion of websites that Dapper can't really do what they're looking to do. And so we strive to continue to make this better all the time. And I can also talk about some of those things. Let's just do a quick demo so that you guys can get the idea. And for those of you who were there this morning, I'm sorry if it's a little repetitive. I just want to give everybody an opportunity to know what's going on. So I'm going to give an example. I used the same example earlier. Let's say you want to build the next great search site. You don't necessarily want to go out and build a search app. You're not Google and you're not Yahoo, and don't necessarily pretend to say I can build a better search index than those guys. But maybe what you want to do is aggregate search information from multiple sources, like MSN search, Google search, Yahoo search, maybe Amazon, maybe Flickr. And you have some really cool idea for a product, right? And you know how you can execute this product. So Dapper comes in where you don't have to focus on how you get the content. It abstracts all of that away from you. You don't have to spend months of your life writing scrapers, trying to understand how this website's structured, doing things like pattern matching, looking for the third space after the second period that's in the 8th paragraph, right? Something that's a lot more robust and reliable than that. And allows you to focus on your core objective in building your app, okay? So let's, just as an example, build a feed for MSN search. Today, MSN doesn't provide a structured access to search results. The only way you can search MSN is by going into your browser and searching it. Right? There's no real way to get a feed of these results. And that would be a necessary component if you were building this sort of aggregator that I talked about. Now, typically, a user would come in and he would type in, MSN or MSN search or search.msn.com in here, and then he'd find other dApps. These are the APIs, we call them dApps, that other users have created. Essentially, I'm just going to skip ahead from that part. The idea is there are about 52,000 of these user-generated APIs. Users generate hundreds of them every day. And so you can find what other people have done, although the process of creating one takes just a few moments. I'm not sure the internet's cooperating with me. It may be possible to do it. Another type of demo. Let's see what we got. Just give me a second to try and load up the internet here. It's moving. It's just moving slowly. So we'll just have to have a little patience. So this part of the process breaks down into two pieces, okay? The first part is that you have to show Dapper what kinds of pages you want to get content from, okay? Basically, every website that has interesting and dynamically changing content adheres to some sort of structure, a template, if you will. So when you do a search at MSN, it doesn't matter if you're searching for, India or America, you get very similarly structured results, okay? So the idea here is to train Dapper, to show Dapper several of these pages. What examples you provide makes no difference whatsoever. The idea is that Dapper will then learn the structure of the page, learn what's dynamic, learn what's static, and learn to extract content in a generic way, so that tomorrow, when one of your users types in a search that you never thought of, it will actually be able to extract it from the website. Does that make sense? That part? Okay, good. This is a non-trivial part of the technology because while MSN's website's relatively simple, it's a simple get structure. You fill in the form and it does a get on the website and brings back results. There's sites that are much more complicated, right, in the sense that they might use DHTML, JavaScript, Ajax to fill in the page. Maybe you have to log in, it sets cookies and so on. And we also support all of that as well. So the navigation to that content is non-trivial, and so it's a big part of the Dapper experience. So let's go through this first part where we find the types of pages that are of interest. The second part is where we actually indicate what content it is we want to retrieve. Now, a website might have tons of content inside it. When you do a search, then you might get ads and search results and links to pagination and other things that are related searches and so on. And you might want some, all, So you can choose what you want. Now, as you see, we're browsing the MSN website within Dapper. Okay, so again, you're training Dapper to understand what types of pages you want here. So we can do a search for cats. And one thing to note, actually, before I do that, is that you can say that this is a variable input. What that means is that your API, when you're done with it, will accept an input. And it will know to take whatever you provide in that input, which is a get argument in the URL for Dapper, put it into that box. Okay, so we can call this search terms. And we'll search for cats. Now, there's a lot of deep implications with what's going on here, and maybe you guys can see the notes from today's talk. All of this pertains to the semantic understanding of websites, and I won't get too deep into that here. The topic here is really how we can take content from multiple sources and mash it up in interesting ways. Yes. We supply the website with Firefox. We discovered, there was sort of a debate. Should we issue a custom user agent that says Dapper so websites could identify us, or should we use one that sort of mimics a browser? And what we found was that many websites just sort of break if you don't supply them with some sort of legitimate user agent. It's websites as big as Amazon, and they do very bizarre things. Sometimes they will block you intentionally, and sometimes they'll just sort of not function properly. Certain parts of the website don't function properly. Let's see if I can Maybe it will help us. In the meantime, I'll try and do it again. Maybe we can get it to go faster. I think we're just having a little bit of slow internet. It went nicely earlier today.
You also handle sites that bust out of the frame?
Yeah, we do. Because we control the way the JavaScript gets executed, we actually interpret the JavaScript. So what happens is we modify the web page on the fly so that all of the JavaScript events are proxied through our server. That's also why there's a little bit of latency involved. So JavaScript event gets fired, sends off to our server, what should I do with this? And then the server ignores redirects and things like that that aren't proper.
Just one more question.
Yeah, absolutely.
All this fetching is done from the Dapper server and your IP addresses and everything. Does it cause any legal issues or violating some terms and conditions? Because no. No,
absolutely. This is a great question, and it sort of leads into something I can show you. Look, what we've done effectively, in large part, is solve a technological issue. You're going and you're building this really cool aggregator, and you first encounter a technological issue, which is how do you get the content out? And the next thing you encounter is, well, how do I, overcome the rights issues? So there's the terms of service to contend with and so on. The IP address is one thing, but really there's the bigger question of how do you have the legitimacy to use this? And I can show you how we've dealt with that. Our vision for Dapper has always been to make it so that we solve the whole part of the problem. And we've overcome a lot of the intellectual property issues by allowing content owners to specify the ways in which their content can be used. Okay? And so at the most extreme, and this is very rare that it happens, but a content provider can come, he proves that he owns his website by placing a file on his server, and then he can say, I don't want anybody using my content through Dapper, and all the existing dApps stop working. And they return a message that lets you know. Okay, so I added this to our basket. Now, it should be noted, MSN is a site that has multiple pages with the same structure. Not all websites have this. For instance, the New York Times, its homepage, is only one of those, okay? There's no other pages on their site that looks the same. So Dapper does work when there's only one to look at. Again, it really makes no difference what examples I provide. Later, I'll be able to do a search for anything. So I'm just going to add these two pages as examples, and then what we'll do is we'll show you how we can now select what content we want to be in the feed. And I'm going deep into this both because it's, I think it might interest people, but also because it's important to understand why we're building this sort of next step that I'll talk about for the rest of the talk. Okay, so you see, we're proxying the page, and now you can click on different portions of the page. Okay. Now I clicked one of the search result titles, and you'll see that it conveniently highlighted all of them. Now this is not just for fun, right? This isn't just for your convenience so you don't have to click 10 things. That's a nice incentive. But really what's going on here is something much deeper technologically. Dapper analyzed this page and understood that these links are different from these links and different from these links. And they're not different in the HTML sense. They're just links, right? And they don't necessarily even have different attributes. But we figured that you will see them as a cohesive group. But sometimes we're wrong. I chose a site that works well, of course, but sometimes we're wrong. And so what you just do then is you say, well, I only want the indented links. So you can click the ones that aren't indented and it should fix it. And that's the idea, is that Dapper will learn what you're after. And it's not always perfect by any means, but we're making it better and better. You'll notice that it didn't get any of the other stuff, so I'm pretty happy, and I can basically save this as a field. Now when I create a field in this, I'm effectively defining an XML element. My XML feed will now contain elements named whatever I type into this box, okay? So if I type in search result title, I'm effectively ascribing a name to this kind of thing. Now I do a search. Notice I don't call it cat web page title, because that's not what this is. This will work on any search you do on MSN, okay? This is a kind of thing on this page. This is an entity that exists really only on this kind of page. If you were to try and run this DApp on Google's homepage, it won't work because the structure is different, okay? But we call it search result title. Now let's say I want also, the description. So I'll click the description. You see I get them all, and I can type search result description. Now, effectively, we show you a preview that basically says, here's what your feed will contain when you run it, at least on this example, right? We're also working on allowing you to preview it in real time here on other examples to make sure that it's working well across all types of pages like this. And so you'll see that it's hard to know which title relates to which summary, right? So we allow you to introduce additional structure and group things together and call this a search result. And this effectively will be an element in your XML that contains two sub-elements. You'll have an element called search result, an element underneath it called search result title, and an element underneath it called search result description. Okay, does all this make sense so far? Okay, cool. So now I basically save my feed. I give it a name. This is going to be the feed's identifier, and then I can call it, and I'll show you how we do that. MSN demo AS2. I'll say that it's a test DApp. You see that it accepts input terms. All of this stuff, despite our best efforts, we really would have loved for this to be the most simple process in the world, and I hope that at least with me demoing it to you, it seems simple. The fact of the matter is that this is sort of a new kind of product, right? There aren't a whole lot of things out there like this, and so unfortunately, there's a learning curve. We would want the learning curve to be something like, a minute. I think it's more like, an hour. It depends on the kind of person and what they understand. Everybody comes to Dapper with sort of a different agenda and a different purpose in mind. And as a result, certain people take different amounts of time to understand it. And that's a big part of our technological challenge is how do you build an interface that's easy to understand for everybody no matter what their needs are. And we're working on that as well. Yeah?
You did the grouping in the previous step?
Yeah.
Did the grouping happen at the scraping level or at the index level, saying the first title goes with the first result?
Yeah, so the way you group is a kind of an interesting concept. Today we use a pretty brute force mechanism that says, okay, you have a group that contains fields A, B, and C. Whatever field you see first in the output of the website becomes your anchor. So whenever you see B, you start a new group. But there's other ways that we've discussed doing it, and this one works well on most websites. There's some where it doesn't work, and it doesn't work particularly well if you don't have groups that always have the same properties. So for instance, let's say you have YouTube, right? Not every movie has a number of stars, right? So if the number of stars becomes the anchor and then it's missing, you'll get two movies grouped into one. Luckily, they don't usually have the number of stars first. It's usually the title or something that does reoccur. But yeah, we've talked about different mechanisms for doing grouping before.
So in this example, if a search result does not have a description, the grouping will go?
No, because the search result description is second, right? So the title becomes the anchor. What you can do here, though, is say that you only want groups that contain the right number of fields within it. Okay?
So it does not try to do anything like a least common denominator?
No, but it could. We've been talking about doing that a lot. It just turns out that in most cases it's not really necessary. This works for the vast majority of cases. Okay, so I'm going to save this, and now I have this DApp that I can use, okay? And it's really cool. I can consume it in XML as a developer. That's probably what I'm going to do. And so I won't spend too much time on the other stuff. But because we have this generic platform for creating feeds, we've built out an open source infrastructure around it where you can transform our XML format very easily into other common formats. So all of these things were contributed by the community. They just wrote little open source modules, we add them into the system, and that's it. So let's say you, for instance, want to take websites and generate SQL commands from them to insert into some local database. You could write a module that does that. So that's the idea, is that all of this stuff is pretty much useful to non-developers as well. So somebody who's technical but not a developer has no idea how to make an RSS feed could come and use Dapper to make his RSS feed without having to write a single line of code. It's probably not particularly useful for, my grandmother. She's not very technical at all, and I don't know how much she wants to remix content from the web. But for technically savvy people, a lot of these things are very useful. And as we continue to try to lower the bar, it'll become more and more accessible to more people. Okay, so.
Can I get a web service out of this?
So this is a web service, and let's see exactly how that works. Okay, so what you end up with is a REST web service. You said we called it MSN Demo GIDS. So what this page is intended to do is help you understand how you construct the URLs of your new web service, okay? And if you change cats, it'll update the URL, but it's really very simple. You pass the parameter in here. So let's say I type in Bangalore, okay? Now I have a HTTP GET REST-based web service that allows me to query MSN search results. This is really cool, right? Because it's really generic. Rather than build some custom parser that's just for MSN, all you need to do now is write code that parses Dapper's XML. And in fact, we have these pre-prepared SDKs that also the community has contributed so that it automatically takes the XML, puts it into a data structure that you can manipulate. And you'll see here that, I didn't train Dapper for this feed on Bangalore, but it worked really nicely. You have very parsable, easy to deal with results, as opposed to, let's say, what the HTML looks like, which showed up on my other screen again. I don't really know what you can do with all of that, but this is certainly a lot easier to deal with if you're writing something that you want to absorb this content into.
So,
go ahead.
Our understand is that once you train Dapper, it's basically a self-learning algorithm that you are running in the background where it understands the structure of the web page and then goes ahead and builds a kind of information on how do you retrieve it, right? So it works on Amazon.com. Now, how do you deal with the problem? So there are two problems that can occur. The first problem is if the structure of the web page changes dynamically. Right, like most of the news sites, their structure might not be constant thing. It can always change. The second thing is you already trained the algorithmic background to have search.amazon.com, and after a period of time it changes and you don't know about it.
All right, so actually both of those problems are addressed sort of the same way. And there's sort of a sliding scale of permutations in a website, okay? Let's talk about a site. You gave us a very specific example of a site that dynamically changes a lot, but take a site that has user-contributed content, like YouTube. This is a perfect example. You do a search today for cats, and one user, one of the videos has stars and one doesn't. But when you trained it, all the videos had stars, because you did it on some search that was very popular, right? Or, for instance, one user used a lot of formatting in his description, bold, italics, all sorts of stuff, and that doesn't appear tomorrow, right? Because it's different search results coming up. So Dapper was built to handle this, right? The algorithms allow for permutations in the data, and that's because there's a huge number of algorithms running over all the different elements on the page. So what ends up happening is we say, well, one of the algorithms identifies a given element by saying, okay, this thing is a paragraph that 3 levels down has between 1 and 4 divs. Okay? Inside there may be bolds and there may not be bolds. And then we give it a fingerprint based on that. We use a bunch of algorithms like this. Plus we also use the CSS class attribute, and we use XPath. So the right combination of those factors come together to give you reliability in the face of, I would say, small to medium permutations in a web page, okay? Certainly because it's localized structures, they can do whatever they want with other parts of the page too, and that will continue working. Now, what happens, and it happens, when a website is overhauled? Completely change the structure, right? Or let's say the permutation was just too big to really be handled. What happens is that until recently, what we did was we just monitored the output. And we would email the creator of this DApp and let them know. Now, that's nice, and it worked for many people. But if you've got some mission-critical system and you say, well, I can't even tolerate a day or a minute when it's not working, well, we've been trying to deal with that situation too. So there's a number of ways you can actually automatically correct the DApp. And the way you do that, there's 2 sort of main approaches. One is according to content. So imagine you have Amazon, where a book rarely changes its title or its author. So you can figure out where the content moved, figure out what the new fingerprint is, and update the DApp on the fly. The other way to do it, which is less trivial, but probably more interesting, is for a site like YouTube, right? YouTube, in general, it doesn't matter what they do to their website. When you search, there's going to be search results, and there's going to be some structure. There might be 10 of these elements, and they might all have some sort of common characteristics. And the structure may be very different than it used to be, but there's a way you can relate those structures to one another. You can see within this one example, this structure was very much like the other 9 things that followed it, and in this one too. So apparently this structure was updated with this one. There are ways to automatically correct it. Yeah?
I was completely fascinated by the demo which you did, but my next question was that, right now it's showing only the 10 results on the first page.
Yeah.
Can I get all the 20? And
So that's what the next part of the talk talks about.
Okay.
This is great. This is a fantastic question because it leads into, okay, you've managed to get one web page. Now, mashups, are usually not one web page. That's the whole definition of a mashup. You take content from multiple sources, you put it together, or maybe multiple pages from the same source. We call that pagination. It's a feature that's been requested by our users since day one. What I'm going to show you, this framework that we've built out, allows you to do that. Before I go into that, I saw some other hands. Yeah?
What I see is you pick up the text from there and display it over here. What if we require the outer HTML or something like that?
Excuse, I didn't understand.
The HTML surrounding the
Yes. What about it?
would we be able to get that somehow?
Yeah, so that's also another requested feature. I think the question is that sometimes you want to retain the HTML because it contains interesting formatting and so on. We retain very, very specific portions, right? In that, we do extract links, images, and so on. If you wanted to retain the HTML, today Dapper doesn't do that. But we've been asked many times that say, I want to take this, I basically want to clip a portion of the website, not just the content, but also the formatting. Because, they did a nice job, they put all these things in there, and I don't want to have to reconstruct their HTML after the fact, right? We've been asked a lot. It doesn't exist yet.
So you mentioned that you handle login and all that.
Yeah.
So does it support encrypted parameters?
Yeah. So the way it works with login, we have a web service where you can pass your username and password over HTTPS if you like, in a post or in a GET. And then we send you back the encrypted one using our key. And from then on, you can pass those encrypted parameters in the URL. However, if you prefer not to, you can also post all the parameters to Dapper over HTTPS. So encrypted or not encrypted using our key, doesn't matter. The advantage, of course, to using post, even if it was encrypted, is that it never shows up in any logs and nobody can sort of act as you. So yeah, so we do support all of that. There's still a matter of trust for what it's worth. You're giving us your username and password. You have to trust us that we're not storing it, we're not giving it to other people, that we treat it securely. But that's we've considered also offloading that to the client. So you might have an SDK that does that part for you, obtains the right HTML, and then sends the HTML to us, and we never have to even see your username and password. So there's options like that as well.
And if you need to work against a server behind the corporate firewall.
Yeah, we don't support that. I smile because this is an interesting question. We probably get something like 10 requests a week from companies, people at companies. And I think it's an indication of the state of intranet data, right? There's a lot of legacy systems. They don't cooperate nicely with the newer systems. You might want to make a better interface for it. There's a lot of value. It's clear. Because of the number of requests we get, it's really clear. Our model is different. We're not an enterprise software company. We're not selling enterprise software. My guess is it will happen someday once we find the right arrangement or once we've pursued our current model, which I'll be happy to discuss as well. But yeah, the enterprise is a very, very rich place for something like Dapper. There are, for what it's worth too, and to promote some of our quote-unquote competitors, there are solutions that fall in the same space as Dapper, like Kapow and Fetch, that do this inside the enterprise. They have a very high price tag, and they themselves claim that they have a 3 to 4 week learning curve. So they're very different products geared at very different people.
Support for microformats?
Support for microformats today, we support them only in the sense that microformats are in the class attribute. We use the class attribute at times to pick up on these categorizations. The natural next extension would be to automatically extract that and pre-name the field for you if you wanted to.
Again, my curiosity is taking over me. Can I, out of all these results, suppose there's a title, and the title has a link to a page. From that page, can I take the content?
I love it because you're prefacing the rest of the talk. This is great. So both of your questions are about to come up, and that's great. I appreciate it. That's the best kinds of questions are the ones that are the next slide. Okay, so I think that I'll breeze through some of this, both in the interest of time and also because you guys really get it because it's technical. But like I said, this is a natural next step, right? And you have to now make a feed, but you still have a lot of work if you want to use that feed, right? Okay, so you've got the nice little things like making an RSS feed or making a Facebook app or making a Flash widget that our user community has made that easier for you. But you want to make some rich mashup, something really interesting like what we described before. It's still a lot of work. You got to take the feeds, you got to make sure you call them correctly, you got to do caching on your end, all sorts of stuff that gets complicated. And if your logic gets complicated, you end up in a situation where you've got lots of code that's just dealing with the data, which is, again, not what you should be focusing on, right? You should be focusing on your app, your interface, your users, your analytics, all the kind of stuff that you should deal with on your own, and not how do you deal with the data. So this is the natural next step for Dapper. I'll disclaim it by saying this was very early on. There's very little documentation about this product on the web, and we're just looking for people to sort of beta test it. We're using it to drive something called Mashup ads, which I'll be very excited to talk to you about as well. But anybody who wants to use it, you just contact me and we'll sort of get you into it, and it'll probably force us to create the documentation and so on. So that would be very good. The goal is to make it easier, like I said, and abstract away those parts that are parts that you shouldn't be dealing with. And it's not really a toy. The concept is that it's something you should be able to rely on. It's not just, for fun. You should be able to build real apps around it. And so service uptime and reliability and performance are critical things to us because we understand that if you're using us as your infrastructure, you need to be able to depend on us. And basically, and we'll see what syntax popularization means in a minute, but we're trying to move beyond that. All right, let's take a very quick look at the ecosystem. 2 years ago, I don't think that there was almost any companies in this space, okay? And it's all sort of popped up. So there's Dapper, and I mentioned Kapow. They sort of sit in the feed creation space, extracting content from sites. There's visual interfaces. I don't know if you guys have heard of Yahoo Pipes, Microsoft Popfly, Lily. These are visual interfaces for doing common programming tasks. So let's say you wanted to do pagination, right? Where you wanted to sort of take results 1 through 10, pages 1 through 10, and funnel them into a single feed. Pipes lets you do that by dragging things onto a little dashboard and then saving in your feed. There's markup languages, like Google's Mashup editor. What they do is they basically extend HTML. They give you new tags. They have a tag, let's say, called list. What it does is it creates a list, and you give it an address of a feed as an attribute of the tag, and it just pulls in the feed and puts it in your list. So it makes things easier in there. And then there's things that are browser-based. Earlier this morning I mentioned Intel's Mashmaker, definitely worth checking out. These are things that allow you to mix up and mash up data within your browser, not create new mashups, but effectively single-person mashups. And I'd be happy to talk about any of these things. So they're going and they're popularizing mashup development, both for developers and also for technical people who aren't developers, okay? And they've been focusing on the syntax barrier. They've been focusing on the fact that it's difficult, the syntax is difficult for doing these things. We talked about Yahoo Pipes and Google Mashup Editor. Our approach is that we sort of say, okay, listen, syntax popularization is an important thing, but we want to go beyond that, provide another piece of the puzzle. And they're in something more powerful for developers and engineers and for ourselves as well. We use the same framework for our product. And so effectively, we've introduced a bunch of mashup design patterns. These patterns oftentimes you'll find them in a computer science textbook. You won't find them referred to as mashup anything. And these certain patterns pertain specifically to mashups in a very unique way. And you mentioned 2 of those patterns. And we'll discuss what they are. We've given them names. Nobody else really calls them by these things. This is okay. It's something so that we can talk about it, so we can understand what these practices are. And we've also built an engine to execute these exact patterns. Okay, so we'll talk about what all that means. Let's talk first about the different kinds of mashups, because this frames the different kinds of patterns. So there's horizontal mashups, right? And when I say horizontal, you take content from disparate sources. Content's not necessarily related to itself, right? The example I gave was great, the multiple search engine thing, right? You bring results from Google and from MSN. You're not taking results from MSN and sticking them into Google, right? So that's horizontal in the sense that it spreads out nicely across the stack. And there's a million examples. Google News is a great example. They bring in content from all these different newspapers and show it to you in one unified interface. You could be looking at a map that shows you, events and coffee shops. These things are not related to it. Price comparison. You might build a mashup that shows you the same product from Amazon and from eBay. And a video search engine that brings you results from YouTube and MySpace and so on. And then you got vertical mashups, which are sort of the inverse, right? You take content from one place and you take that content's output and you provide it as input to some other source. So a great example of something like that, and it's what we call linking, is let's say you have, you read the newspaper in English and you have some other feed using Dapper or otherwise that allows you to take text in English and translates it to Spanish. You can plug these 2 things together and then read your newspaper in Spanish instead of manually copying and pasting every day. And so you can do all sorts of things like that, right? The other patterns, I'm going to get into them in depth, and they do reflect what you were asking about. These are just some more examples, just to really sort of drive home the concept of how content can relate to one another. So let's say you're building a flight search tool. So a user says, I want to fly from New York to Bangalore. So first you got to use some source to find what airports exist near New York and which airports exist near Bangalore. Then you got to use some other source to link between those, to find flights between those. Okay? And then you execute your logic, which is show them the best prices and so on. You also, for widgets, and contextualize, you could do something really cool, which is, okay, I'm going to use content from whatever page the widget's being shown on as input to some other source. So imagine you have a camera review website, like dpreview.com. Okay? You could, for instance, extract the name of the camera from that page. So your widget knows I'm on dpreview.com/Canon 30D. And he extracts either from the page or from the URL the model of the camera. and he supplies that as input to Flickr. And Flickr will give back pictures taken with that camera. And so now you've got a really cool widget. All you need to do is embed that widget on your page. It figures out what page it's on. It finds pictures by that camera, and you don't really have to do any work. And I'll show you how all that kind of stuff is built. So how does it all get executed? Using the Dapper feed service, or what I also intermittently call the Mashup data server. It's a server-side Mashup engine, okay? It means you don't, in your code, have to do the logic of, okay, take the output of this and pipe it into the input of this, okay? It implements the different patterns that we're going to go into. It uses a repository of predefined Mashup configurations, okay? I'm going to talk about what that means, and I'm going to show you some really detailed examples of what these configuration files are. They're XML files. They define which patterns you're using, which content sources you're using. This is the way you set this thing up so that it'll actually work. It receives parameters on the fly. Like I said, if you're building this widget thing, it might receive the parameter of what page it's being shown on. It might also, if you're building something for travel, you might want to get the user's IP so that you can find out where he is and show him flights from his city. And the most important part is that it just returns an XML feed back to you that has everything that you really need for your app. The idea being that it should be in its final form. You shouldn't have to now take another step and combine it and so on. You get the mashed up results in XML. And clearly, this is a tool for developers because it brings back XML, right? So why is it good? Like I've been talking about, it abstracts away the common work. It's silly that you should have to write something that does this linking between two sources, and he should on the other side of town, and he should on the other side, and you just have all this duplicated code. Furthermore, you're building this video mashup, and when you build it, unless you're an incredibly disciplined engineer, what you'll end up doing is you'll have your Google class and your MSN class, and they'll each directly deal with the source. And you might not realize, well, tomorrow I might want to build a video search aggregator, and you have to write all your code again, and it's going to be a big mess. So this abstracts away all that common stuff. The patterns guide you when you're thinking about the mashup that you want to build. You think, how does the content relate to one another? What pattern does this fall under? Programmability. So you can also program around the content, but you can also even write code that produces these mashup configurations. Reusability we talked about. And the cool thing is because it just outputs a feed, it works with all of the other tools that we talked about because those things ingest feeds, right? Oh. Let's look at this example that I explained. I explained this already, so I won't rehash it. The idea is that it extracts the name of the camera, pipes it into a Flickr DApp, and there you get pictures taken with it, right? And it figures out, you can tell the mashup, I need you to get the URL of the page that it's being displayed on. Okay, so I can talk about the patterns now, and this will go to answer some of those questions. By far, this is not all the patterns that exist, but these are the major ones that we've identified. So, recursive. This goes to the MSN example, where you want to extract multiple pages. Now, there's kind of two ways to do it. Let's say you do a search for cats, and there's 80 pages of results, right? Okay, so there's two things you can do. You can either write in your code a for each loop, right? That would say for 1 to 80, construct the URL, pass that URL to Dapper, because a DApp takes a URL. You pass the URL, it will work on that page, right? So you can pass all that to it and then fetch it and combine it. But the real problem is how do you know when it ends, right? How do you know how many pages there are? So if you use a recursive model, basically what you can do is something like this. And I'm going to use Google as an example. So you have a DApp that extracts the results from this Google search, okay? Your DApp includes the titles, okay? But you can also get it to include the next link. Now, recursion, how does it work? You have a base case. While there is a next link, continue extracting it, and when there's no next link, you're done. Nothing else to do, right? So that's exactly the pattern you can do. You can say, use this field, take this property out of the field, in this case the href, use that as input to myself, and keep going until there's no such next link. Okay? And so that's how you could use this to extract all the results from all those pages. And you'll end up with a feed that has all the search results and all the descriptions from all those pages. And that's how we'll know how many to do.
And is this visually or is this done by the API?
This is explained and defined through the XML configuration of the mashup. Okay? And I'll show you how those. So here, let me give you sort of a background. We've basically built the back end. Okay? Now we also have a Mashup Ads product, right? Now Mashup Ads, what it is you come in and you can build an ad. You say, I'm the advertiser, this is my content, I want it to be in the ad, I want you to use this content from the publisher, this should be the input from the publisher into my DApp. So for instance, let's say you're a travel website. This is an ad that we're currently running for a major online travel agency. The way it works is and I can show you how it works, it's really cool. The ad runs, let's say, on a travel guide website. So they have information about cities all over the world. So let's say you're visiting a page about San Francisco. So the way the mashup is set up, it says, on this page, use this DAP. And how do you know this page? You use a regular expression. You say concierge.com/destination, and then the next bit is the name of the city. Okay? Use that as input to this other DAP, which is the advertiser's DAP, and bring it back. And we have a product, it's in its infancy, that allows you to create this XML file through a visual interface. It's geared towards the advertising industry. Over time, I imagine we'll build something more generic that allows you to do exactly that. And it's possible, too, that it won't be us. It's possible that Pipes will use something like what we have to make that happen. It's possible we would have some sort of partnership and so on. But today, the primary way to construct these files is manually. They're not very complex, though. Okay, let's talk about another pattern. This is the for each, and I alluded to it earlier. And this is exactly your second question. For each is use the same DAP on each of the inputs from a certain list. So let's take CNN. Okay, CNN has these top stories. For each one of these stories, you want to go get the full text of the article. You end up with a huge feed that has the text of every article that is currently on the link to from the top stories section of the CNN page. And how does it work? Well, you have a DAP to get those, and you have a DAP to get that. And you just indicate that this one is the input to this one. And that's it, right? And it's pretty simple. You have two DAPs, the top stories DAP and the CNN story DAP. Because those pages have different structure, that's why you need to have two different DAPs, right? And you end up with a unified output that contains all the results, and I think that goes to answer your second question. So you set me up nicely, thank you.
What is the performance of these sources?
So that's a great question. Again, like I indicated, this is a relatively young product, right? We obviously are highly attuned to performance because we use it in advertising. The sort of core requirement for an ad is that it load in about 70 to 100 milliseconds. We haven't hit that point, right? Our ads load that quickly, but then they usually show a little graphic that says please wait or whatever it is, and I can show you all of that. It's really cool. It depends. It really depends on how you're getting the data. So the performance is limited to a whole number of things. The real question to ask is, how fast does a DAP perform? So the core, the minimum amount of time for it to perform is how long it takes for the other website to send us the data. And websites, have different performance times. Excuse me? Yeah, we cache, DAPs are cached for 10 minutes at a time. Obviously only for the same input. If you did a different search, it would be cached differently. Yeah?
Is there a way to set a delay within by making recursion calls, because some sites do treat this as a robot?
Yeah, so this is actually a great question, and we haven't encountered it so far. I can tell you Pipes did encounter this issue, and we encountered it. It was very interesting because people were building RSS feeds with Dapper and then putting them into Pipes and doing these same patterns, and they were killing us. They were hitting us with 15 times a second, right? And so, yeah, and they've since then allowed content owners to say how often you can hit them and so on. So they're finding standards for that. I can tell you in one example, one of the limitations for one of the ads we're running is that we get throttled. The source website throttles us. They don't let us access their page more than every so often. And so we've had to contend with that in all sorts of interesting ways. Needless to say, this is far from perfect today, but it's being pushed by a real business need on our end, right? We need to use it to sort of promote our own business, and therefore that's how you can be guaranteed that it will support all of this. But to really answer your question, there's several ways. Caching is one way it gets sped up. Again, some of it depends both on how long the website takes to load, but also how complex the website is. Our algorithms aren't free, They do require computational intensity, and so they're not free, and so it adds more overhead. We try to keep that minimum to absolute minimum. And then there's ways to speed it up. For instance, sometimes the data that you need from the source website is in the URL. So you might have a website that looks like lonelyplanet/India, right? You can extract India from the URL. And yeah, you have to do all sorts of massaging to the data that we've already started to deal with, at least with geographic data. You end up with San-Francisco. So you can't provide that as input to something else. And I'll talk about how that's actually dealt with, because we have an abstract way to deal with that. Let's just go over, I think this is one of the last patterns. This one is what we talked about with that search, that horizontal search for meta search, right? So you get 3 DAPs here, it runs them in parallel, and you end up with something like this. This is one of the first things we built with Dapper, so it's just a proof of concept. This is actually the first thing that bloggers wrote about Dapper. We built it because it took us about 25 minutes. We built this, then the rest of the time we spent was all on the UI. And that was about another 2 days. And so people wrote about it. And really what happens is we use a YouTube dApp, a Metacafe dApp, a Veo dApp, and the user types in a search, and it brings back results on the fly from it. Okay, so, yeah, I think we have about 17 minutes left, so that should give us some time. I also want to make sure we have time for more questions. I was referring to this need to clean up massage data. So we have something called an action field. And this is pretty abstract. Now granted, since we own the Mashup data server, we were the only ones with access to the code, we plan to open source parts of it so that people can contribute additional functions. And these are functions that run on fields. So let's say a field is a field in the output of a dApp, or any web service. We plan to also wrap around existing web services and so on. So the field, the action field could transform that content. So for instance, San Francisco, it could know to massage it, create San space Francisco, comma space CA, right? It would know how to normalize. And that's a function that might be called, location normalizer. And you can write any of these functions, we can write any of these functions that do all sorts of stuff, like city to airport code, and so on. IP to location, all these kinds of functions. And we've started to build up a library of these, and over time it would make sense for us to open source that and allow contributions of those kinds of functions. So that gets built right into the Mashup data server, and you can define it in the XML. You say, in my output, make sure that you use this action on this field, and then the output will be correct, the way you'd expected it to be. A little bit more detail on how it works. I said it's an XML file, easily configurable, maybe a little optimistic, but it's getting there. Basically, at runtime, you make a request. It's something like dapper.net/mashup data server, and then you pass some arguments. One of them might be one of them is definitely the ID of your mashup. That's also just the name of the XML file on our service. Another is any other inputs that are needed by the mashup, the URL that you're running it on. So if we need to know what the context is, right? So if we think back to the camera example, let's say your website is greatcamerareviews.com, and you can just pass your URL, greatcamerareviews.com/review/canon30d, and then the Mashup data server will know where to get it from, and that's defined in the XML file as well. Anything else that you might need as input to make the mashup work. And then it runs the mashup, it runs any of the apps it needs, it does stuff in parallel in order to make things as fast as possible. So for a horizontal mashup, it could run everything in parallel. For a vertical mashup, it would effectively be sequential. And then it sends back the resulting feed. And you can do whatever you want with that feed, right? You can render it as a widget, you can use it in your back-end logic. Let's just motivate this with an example. This is Ticketmaster. This is a big website for ticket sales in the United States. They sell tickets for sporting events, for music events. And let's say, although I don't know that Ticketmaster will be using this anytime soon, let's say they wanted to embed a map on each one of their pages that shows, the order, the tour. This is the band's tour, effectively, right? Okay, so how would they do that? They could create a dApp, first of all, for their page. And they don't have to use a dApp. They could provide a feed of their own if they wanted to. But they could easily create a dApp that extracts the locations, the dates, the cities, and so on. And what basically would happen is that Mashup would know the Mashup configuration would contain which dApp it's using. And they would, when they call this, basically what their code does here, just to be clear, is they have a little piece of code, maybe it's PHP. If their website's in PHP, they have a little piece of code, which what it does is it says, okay, for this page, I need to pass Dapper the URL that I'm on. Dapper then says, okay, I know that this mashup, what I need to do is extract the date and location. For each date and location, there's the for each pattern, do a latitude longitude lookup and deliver that back in the feed. Then they would use the latitude and longitude with the Google Maps API, and they would plot each one of those spots. That saves them the need to parse their own information, do the conversion to the latitude and longitude themselves. And just as a motivation, even if it's not particularly real world, this is what the XML starts to look like. I'm not showing all the XML, but effectively we've got something like the type of pattern, which is simple contextual. It's a contextual mashup, which means that it requires to know what page it's on. And we'd say context. So when you are on a page like ticketmaster.com/artist/anything, then what you want to do is use this dApp to extract the content. Okay? Now, here's all sorts of cool stuff, and this gets into caching. So we say this is a dApp. We're using this dApp. You need to have the apply to URL, the page on Ticketmaster that you want to extract the content. Then you can say all sorts of stuff about caching. How long should I use a cache for? Right? So let's say 24 hours, we only update our tour dates every 24 hours anyway, so there's no need to refetch it from our servers more than every 24 hours. However, let's say there's some problem. I don't know, there's network congestion, you can't get it, something's broken. How long can I use old data for until it's just, you really should break? So they can say 72 hours. And then you can do validation, which says, make sure that you only put things on the map, only do this work for things that have a date, place, and city and state, okay? As opposed to, if it's missing data, then you don't necessarily want to put it on the map because it might break or it's not what you want and so on. And then, this is how you define what you want your output to look like. You want your output to have a group called show, like constant, right? And then there should be a field in there called date, okay? And you want to format it in this format. I don't know, maybe you guys put the date before the month, and so that's more relevant to you guys. And you can define the data type. So we can actually validate and say, hey, this is garbage, this isn't a date, what I'm supposed to do with it. What feed you got the input from. You can say, I want the date feed field, right, from the Ticketmaster tour dates down. Okay? And the same thing for venue, same thing for city and state. I don't think that, there's no action fields in here, but you could define in here an action field, which is, you would basically say, transform this using this action. And then your output looks like what we just defined. You have a group called show, okay? You have date, venue, city, right? And it's formatted it, Reno, comma, Nevada. Even if on the website it was just Reno. And you have multiple groups, and then you can use all of that and plot them on your map, and you see that it got back longitude and latitude, and makes this whole process much easier because you don't actually have to execute this logic. This logic gets executed directly by the Mashup data server, Dapper server. Okay, I'm going to give you a contextual, yeah?
Just to clear a bit up, all this the three XML files, the feed and the group which you showed was pertaining to a particular Dapper, which I'm just trying to, where do I add that? The thing you created with UI, which actually generated that content? And
Well, first of all, I went through this really fast. I don't expect anybody to be able to construct an XML file like this now after this.
Where does it go and how does it fit into it?
Well, it does become the map.
What's that? How does it become the map?
I think the travel website, whatever we showed, the ticket master.
Yes.
This is the configuration.
So that's the website of the customer, right?
Well, yeah, in this case, Ticketmaster is the one implementing the mashup, which is a map, right? So the question, just to clarify,
Does Dapper do all this for me?
Dapper creates this output for you. You then have to take that output and create the map with it.
No, I guess what you're asking
Okay,
where do you...
no, I'm not talking about the map part. I'm talking about the two slides for the configuration of the Dapper, which I configure manually, or we are using the visual.
You mean the DApp that gets this content?
The root, the XML, the two XML keys that you showed.
Yeah, this is all one file, by the way.
Okay.
Okay.
This is the configuration of the Dapper,
No, yeah, this is the configuration of the mashup.
of the mashup.
Right. There is no configuration of the DApp. The DApp is that you create using that visual interface I showed you before on MSN. You just do the same process, but for Ticketmaster. You'd say show, you'd say place, city, date, yeah? Okay, so it makes sense, right? You have, that part you don't have to write any XML for. You have a feed, and Dapper's mashup engine knows how to work with those existing feeds.
So this mashup is put up by Ticketmaster?
Yeah, so Ticketmaster, what they would do is, it basically, and this may not be the most fantastic example because it may have just been easier for them in the first place to query their database, get the locations out, and use some very simple tool to do, Google in their API gives you the ability to translate a city to a latitude and longitude, okay? They're telling me I have 5 minutes left. I'll give you one, belabor the point. A lot of this stuff is the same. You define what the DApp is, you define what kinds of pages it runs on. And the reason we have this, by the way, is maybe you want to run it on cars.com and edmunds.com. Two sites that, are, and the customer here is Maroon, the advertiser, right? They want their widget to be on many people's websites. And so they can define it should work on this page, and when it's on this page, use this DApp. And when it's on this site, use this DApp, okay? And that's what they can define in the XML. This is the same notion of the validation and the caching, so I won't go too far into it. This one gets a little more complicated because there's actually input variables. You would say that you have a model, which is a string, and it goes into a specific context, and you would have it from the DApp and so on. Zip code as well. And the zip code has a default value, but you would use here is a action field, function location to zip code. We get the user's location using GUIP. It gives you maybe Boston. And we need to convert that to a zip code because their website, the DApp from Maroon, requires that you enter a zip code and not a location. So these are all things that, I know we're going through them very quickly. But I think that sort of conveys the point. And given the time limit, would you guys be interested in seeing one more example of something that's actually running? Let's take a look. See if I can get it to load. This is an ad that's running for Expedia. For those of you who don't know, Expedia is the largest online travel agency in the world. This is an ad that they commissioned and that they paid for that runs on two sites, concierge.com and travelandleisure.com. These are sort of travel guide websites. And I don't know, I presume it probably won't see the ad because we're in India and maybe they don't show the same ads in India as they do in the United States. Yeah, that's our ad right there. Okay, so it uses one of these Mashup configuration files. Okay, and it's really cool, right? It extracted San Francisco from here. Actually, I think we used the URL. And then it brought you back hotels from Expedia in San Francisco, and you can flip between them, and you can make a reservation and so on directly from within the map. And this is all powered using that framework that I just showed you. This whole thing, basically what there is in here is there's a Swift file, a Flash file. Inside the Flash, there's just a call to the Mashup data server with this right ID, Expedia whatever, and then the Mashup runs it and gives back the feed, and the ActionScript code in Flash renders it, okay? I think we're just about to run out of time, but we can...
It's actually a different frame in the browser, right?
It depends how the ad network puts it in. They either put it in ad frame or they just put the Flash embed directly to the page.
So can we explain the data between this frame and that frame is variable? If I have to pass some data from this frame to...
We don't pass the data. What actually happens is the Swift code uses JavaScript to get this URL. It passes that URL back to Dapper. Dapper loads this page, extracts the content, and sends back the right information to the ad. Does that make sense? It's not, the frames aren't talking to each other. This guy doesn't talk to him. All he knows is what URL he's embedded on. He uses JavaScript. He says, what's the URL? So he does something like top.window.location, okay, which gives him the URL, this one, Travel and Leisure Guide Centers. That's sent back to Dapper in its request. The ad says, Dapper, give me the results that I need for Mashup called Expedia with input Travel and Leisure Guide San Francisco, right? And then Dapper says, okay, the way this Mashup is executed is that I have to run dapx on this URL, extract the information, okay, supply that as input to the Expedia dap, and bring back results.
So this page is rendered by Dapper server?
No, just the ad is rendered by us. Yeah.
Who creates the dap on this page?
Well, with the client like Expedia, we create the dap. Typically the idea, and they're a very big customer, typically the idea is that we have, and this goes back to this question about how you create the XML, typically we have a visual interface that people walk through, and it creates the XML, and they create the dap as part of this process.
But shouldn't the publisher be creating the dap?
No. Actually, it's the other way around. The advertiser is the one who has the incentive. He's the one who wants to create the ad. That's how it works. In the advertising industry, advertisers always create their own ads. They want to be in charge of their own messaging and branding. The publisher, in fact, I don't think this publisher knows what this thing is doing. Publisher just sees an ad and they're like, wow, that's a cool ad, you know? That's different than what we've seen. But it's great because the publisher doesn't even need to be involved. He doesn't need to know.
This configuration file, is it open for people to try out?
Yeah, I'll be happy to explain. Again, because it's like a product that's only sort of soft launch, all you need to do is email me, Jon@dapper.net, Jon@dapper.net, and I'll be happy to share anything and the slides and everything as well with you guys. Examples of the XML files for this stuff. All of this stuff we're very happy to be open with it.
Would you be able to extract some behavior parts of it?
Well, that's an interesting, the behavioral advertising is a very sort of hot space. We're not really a behavioral company. You could, in theory, behavioral requires presence on the web, right? If you want to be able to see what users are doing across multiple websites, it means you need to have code running on those websites, which means you have to be hosting ads on lots of websites. So for us to build up that network will take time. However, if you deploy your ad through something like DoubleClick or iBlaster, and they give you access to that, you can certainly use it from within your Swift code, right? Cool? Yeah, sure.
Regarding the login part, like, you will give me a demo of the login, but
Yeah.
suppose you have a login. So will it cache the login credentials and does it, will it do a login for every instance?
It does do a login every time because we don't store your credentials. It's expensive. We've thought about it a lot, but yeah, we should in theory cache the cookie and not the credentials, you know. We've talked about it too because if you're going to start using this pattern where you want to fetch multiple pages, to do a login for every fetch is, I mean, the website will eventually just delete your account or something, you know, it's crazy. Sure. Thank you guys. Thank you, everybody.
Appreciate it.